Hey everyone, and welcome back for another deep dive. Today we are going to be looking at something really cool.
Yeah,
Planet formation.
really exciting stuff.
I know, right?
Yeah.
Like the birth of worlds.
Exactly.
So we're talking about the invisible forces that shape planets as they're born.
Uh-huh.
So, okay.
Yeah.
Picture this.
Okay.
You've got a young star, burning bright,
Right.
surrounded by a swirling disk of gas and dust.
Like a cosmic construction site?
Exactly. It's like a cosmic construction site.
Yeah.
And so scientists have suspected for a long time that magnetic fields play a key role
Uh-huh.
in how those raw materials come together to form planets.
Yeah, they've been really hard to observe directly, though.
Yeah, that's the catch, right? Magnetic fields are invisible.
They are.
So how do you study something you can't even see?
Well, that's where this new research comes in.
Okay.
They found a way to actually see the magnetic field around a young star.
Whoa, hold on.
Yeah.
How'd they do that?
Using dust particles as tiny little compasses.
Dust grains as compasses.
Yeah.
Okay, now that's seriously clever. So how does that even work?
Well, it's pretty fascinating. So
Okay.
you've got this young star,
Uh-huh.
and it's surrounded by a swirling disk of gas and dust.
Right, the protoplanetary disk.
Yeah, exactly.
Okay.
And within that disk, there are these tiny dust grains.
Right.
And those dust grains are sensitive to magnetic fields.
Okay, so they're kind of like iron filings around a bar magnet, right?
Exactly.
They line up along the field lines.
It's the same principle.
Got it.
These dust grains align themselves with the magnetic field lines.
Uh-huh.
And by observing that alignment, scientists can essentially trace out the shape of the magnetic field.
So it's like the dust is revealing a hidden blueprint of the magnetic field.
Yeah, like a secret code.
Okay? And this is something they've never been able to do before.
That's right.
Wow.
This is the first time scientists have been able to map the 3D structure of a magnetic field
Really?
around a young star.
Huh.
The star they focused on is called HD 142527.
HD 142527.
It's about 512 light years away from us in the Lupus constellation.
Okay, 512 light years. That's pretty far out there.
It is.
But with this new technique,
Yeah,
they're essentially seeing the invisible right.
that's right.
So what are they seeing? What does this magnetic field actually look like?
Well, the specific magnetic field structure they observed around HD 142527 is pretty interesting.
Okay, I'm listening.
It suggests there's a lot of turbulence in the disk.
Turbulence, huh?
Yeah.
So it's not just a nice, calm, organized disk.
It's not.
Things are getting a little rowdy in there.
Exactly. And that turbulence could be a key factor in how dust grains clump together to form larger and larger objects.
Oh, so like a cosmic washing machine?
Yeah, think of it like that.
Okay.
Shaking things up and helping those dust particles collide and stick to each other.
Okay. I'm starting to see how this all fits together.
Yeah.
We've got this young star
Right.
surrounded by a swirling disk of gas and dust.
Uh-huh.
The dust grains are acting like tiny compasses, revealing the shape of the magnetic field.
Right.
And that magnetic field is creating turbulence in the disk,
Uh-huh.
which could be crucial for getting those dust particles to clump together
Yeah.
and eventually form planets.
Exactly.
I'm already hooked. Tell me more.
All right. It's like these magnetic fields are almost like a cosmic sculptor, right?
The cosmic sculptor. I like that. So if different magnetic fields lead to different types of planets,
Uh-huh.
what kind of planets do we think might form in a system like HD 142527 with all that turbulence?
Well, it's hard to say for sure.
Yeah.
Based on what we've seen so far, it
Yeah.
seems like there's a good chance that some pretty massive planets could form in that system.
Really?
Yeah.
So we could be talking like gas giants like
Yeah.
Jupiter or Saturn?
Possibly, yeah. Imagine a strong magnetic field acting like a cosmic shepherd,
Okay.
corralling all that gas and dust in the disk and guiding it toward the growing protoplanets.
Right.
This could lead to the formation of some seriously hefty worlds.
Right. Wow. So you're saying that the magnetic field could be playing a role in creating like the diversity of planets we see across the universe?
Absolutely.
Because not every planetary system looks like our own solar system.
No, not at all.
There's a lot of variety out there.
There is. Yeah,
Okay.
it's one of the big mysteries in astronomy.
Really?
Why we see such a wide range of planetary systems.
Okay.
Some systems have giant planets orbiting really close to their star,
Oh.
while others have smaller rocky planets further out.
Right.
And some systems are just incredibly chaotic,
Wow.
with planets on these wildly tilted orbits.
So are you saying that these magnetic fields, these invisible forces,
Yeah.
could be one of the missing pieces of the puzzle.
That's what's so exciting about this research. It's
Yeah.
really giving us a whole new way to think about how planetary systems evolve.
Okay.
Different magnetic field configurations
Uh-huh.
could lead to different types of planets forming.
So walk me through this.
Okay.
How would that actually work?
Like, how could a magnetic field actually influence what kind of planet forms?
All right, let's imagine two scenarios.
Okay, I'm picturing it.
First,
Yeah.
let's consider a star with a really strong, well-organized magnetic field.
Okay.
In this case, the magnetic field might act like a cosmic traffic cop,
Yeah.
keeping the dust and gas flowing smoothly in the disk,
Uh-huh.
creating the conditions for larger, more massive planets to form.
Okay, so it's like a well-maintained highway system.
Exactly.
Everything runs smoothly.
Yeah.
Got it.
Now imagine a star with a much weaker, more chaotic magnetic field.
Okay.
In this case,
Yeah.
the dust and gas wouldn't be so neatly organized.
Mhm.
It'd be more like rush hour in a city with no traffic lights.
Oh, okay.
A little more chaotic.
Right.
And this chaotic environment
Yeah.
might actually favor the formation of smaller rocky planets.
Like our own Earth.
Exact.
So a strong, organized magnetic field,
Yeah.
big planets.
Uh-huh.
Weaker, more chaotic magnetic field,
Right.
smaller planets.
Potentially, yeah. That's interesting. Almost counterintuitive.
It is, yeah.
So essentially the magnetic field is like setting the stage for the whole planetary system,
Yeah,
influencing what kind of planets will ultimately emerge.
I got it.
I'm curious, do we know what kind of magnetic field our own sun had when it was young?
Ooh, that's a great question.
Yeah.
Unfortunately, we don't have a time machine to go back and look.
Right.
But
Yeah.
we can look at the structure of our solar system.
Uh-huh.
And based on that, with the inner rocky planets and the outer gas giants,
Yeah.
it's likely that our sun had a magnetic field that changed over time.
It changed over time. What do you mean?
Well, as stars age,
Yeah.
their magnetic fields can evolve and become more complex.
Uh-huh.
It's possible that our sun started with a strong, organized magnetic field,
Right.
which allowed for the formation of the gas giants.
Right.
But as the sun aged and its magnetic field weakened,
Yeah.
it created the conditions for the smaller rocky planets closer in.
So it's not just about the initial state of the magnetic field.
Right.
It's also how it changes over time.
Exactly.
It adds like a whole other layer of complexity to this.
Absolutely. And that's what makes this research so exciting.
Yeah.
We're starting to unravel this really intricate dance between magnetic fields and planet formation.
And this is just the beginning, right?
Yeah.
Now that scientists can actually see these magnetic fields,
Mhm.
they can study them in much greater detail.
Absolutely.
Wow.
This is opening up a whole new window into the universe.
Yeah.
Imagine being able to observe the magnetic fields around dozens,
Yeah.
even hundreds of young stars.
Right.
We could see how those fields evolve over time,
Uh-huh.
how they influence the formation of different types of planets.
Wow.
It's a really incredible opportunity.
It's mind-blowing to think that these invisible forces are playing such a crucial role
Yeah.
in shaping the universe as we know it.
I know, it's pretty amazing.
You know, it's amazing to think how far we've come in our understanding of the universe. Like for centuries, we could only look at the stars and planets with our naked eyes.
Uh-huh.
Then we got telescopes.
Right.
And now with techniques like this,
Yeah.
we can see the invisible,
Right.
like uncover these hidden forces that shape the cosmos.
It really speaks to our human curiosity
It,
and this pursuit of knowledge.
yeah.
We're always pushing the boundaries of what's possible.
Uh-huh.
And this is a great example of that.
It is. Who would have thought that dust grains would be the key
Right.
to unlocking the secrets of magnetic fields and planet formation?
It's amazing.
It really is.
And this is just the beginning.
Oh, really?
Yeah, this technique could completely change how we understand things,
Okay.
not just planet formation,
Yeah.
star formation, galaxy evolution,
Wow.
maybe even the origins of the universe itself.
So this is much bigger than just planets.
It
We're
is
talking about understanding
yeah,
like the fundamental building blocks of the universe.
pretty profound stuff.
It is.
It all goes back to those dust grains,
Right.
acting like cosmic messengers,
I like that.
revealing those secrets of magnetic fields
Yeah.
that have been hidden for billions of years.
Makes you wonder what other secrets are out there just waiting
I know, right?
to be discovered.
Yeah.
What other invisible forces are out there
Yeah.
shaping the universe around us?
Well, that's the beauty of science.
Okay.
This never-ending journey of exploration and discovery.
Yeah.
There's always something new to learn,
Mm-hmm.
a new mystery to unravel.
Right.
And every time we make a new discovery,
Yeah.
our understanding of the universe
Mm-hmm.
and our place in it just grows deeper and richer.
It's like peeling back the layers of an onion.
Yeah.
Just revealing more and more complexity with every layer.
Absolutely.
And it just makes me more curious.
Yeah, me too.
Like we've only just scratched the surface of what's out there.
We've got a lot more to learn.
We do.
But that's what makes it so exciting.
It does.
There's a whole universe out there waiting to be explored.
Yeah.
And with tools like this, we're getting closer and closer to unlocking its secrets.
So as we wrap up this deep dive into these magnetic forces shaping new worlds,
Yeah.
I want to leave our listeners with a thought.
Okay.
If we can now see these invisible magnetic fields,
Mm-hmm.
what other hidden forces are out there in the universe
Yeah.
that we might uncover next?
A great question.
What other keys are waiting to be found?
I don't know, but I can't wait to find out.
Me neither. The universe is full of wonders, and I, for one, can't wait to see what we discover next.
Me too.
Thanks for joining us.